welcome to the medium category. Congratulations if you've worked through the very easy and easy categories. We'll start a new one, and correspondingly we'll probably pick up the pace a little bit and not talk about the very basics in this series. So this one's called array of multiples. You are to create a function that takes two numbers as arguments, num and length, and returns an array of multiples of num up to length. So let's look at the examples. First one, we have 7 and 5. So we're going to start with num, which is 7, and we're going to produce 5 multiples total of it. So we'll count the 7 as one multiple. Multiply that by 7, you get 14. Again, or I should say 7 by 3 is 21. This would be 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5. So we produced an array with 5 elements as specified, and they are the multiples of 7 starting at 7. And so feel free to do the math on these remaining two to make that clear. The notes say, notice that num is also included in the returned array. We mentioned that, so I think we're good there. We'll head over to code. Okay, now is the time to pause and implement this. Resume when you're ready. Okay, I'm going to use this enumerable class for my solution. I'm going to do a couple different ones using link methods just to get some more exposure there. The first one's gonna be not so good, but we'll show a couple methods and then I'll do what I think is a better one. So first of all, you might look through. You can expand enumerable here and see what kind of methods you have at your disposal. And so what if we did range like this, right? You can give it a start number and a count, and it will give you consecutive integers in that range. So they did 1 to 10. Notice that this range itself produces those numbers 1, 2, 3, 4, 5, etc. up to 10, but they had an additional select statement that was squaring all of those values. But just know that range does produce the numbers 1 to 10 itself. So what if you said, hey, why don't we say then enumerable range, and you could say num times length, right? And so if we think of that initial case of 7 and 5, what this will do is start with the number 7 and produce all the numbers up to 7 times 5, which is 35. So that's 7, 8, 9, 10, 11, 12, etc. Then you could think, hey, I'll use that filter we did in the past where, and I'll just say modulo the num equals 0, right? The even multiples. That's all I want. And everything else is going to get discarded by this filter. Feel free to consult where if you don't recall that from the previous videos. But it'll filter on this condition right here. And so the even multiples are going to get through by this statement. 14 modulo 7 will be equal to 0. Same for 21. And okay, that's all well and good. Remember, this returns an IEnumerable, so you have to convert it explicitly to an array, which is what they wanted here. And you could do this. I think this should work. We'll probably need to bring in link. But hopefully this raises some flags for you. You might be a little suspicious of this. But it works, right? It passed all the tests. It did what it was supposed to. It's appealing, right? It's a nice one-liner that's very readable. You might be tempted to think it's very efficient for that reason because we only used one line, even though these methods sort of wrap up some things going on under the hood with the actual implementation. So they're not necessarily as efficient as they may appear. But you might be thinking, or if you would like, pause the video and try and think where we could improve upon this. So we created this giant range of a lot of numbers that they weren't even relevant, right? They weren't multiples of 7. And so that was pretty wasteful in terms of space. Not a big deal with 7 and 5, but start putting some large values in here and you make this gigantic collection, and that's really bad. So is there a way we can be more responsible with our link usage? And I would say the answer to that question is yes. I'm going to refresh and get us a clean slate here. Okay, back to the code. We know the rules. We're gonna do better this time. We're going to return enumerable, and let's do this repeat. That sounds appealing. Generates a sequence that contains one repeated value. Okay, I think we can leverage that. So what if we said repeat num length? So what would this mean? This would mean take the number, we'll use our first example 7, and make length size collection of that same value. So this would be 77777. It would be a collection like that, 5 7s. Okay, that's a start. This is nice, right? Because we only created enough elements that we need for this length. We're not creating a bunch of excessive space. So how would you transform all of these 7s into their multiples? I'm going to do that with a local variable here. Initialize it at 0, call it multiple. And then, if you remember another enumerable method we've looked at, it's this select. And what does select do? Projects each element of a sequence into a new form. That sounds pretty good, right? We technically don't need our new, the first element in our sequence projected into a new form because it's correct, right? That 7 value is what we want for the first entry. But we can easily work with that. So if we said, we have our collection here, what if we select, and I'm going to use n as my variable name in my lambda. I'm going to say, with this n, whatever number you give me, I'm going to multiply it by the multiple. And I use this pre-increment operator here, so it was 0 the first time through, right? And this will make sure that the multiple variable gets updated immediately before this multiplication. So what does that mean? Multiple goes to 1. Our first value is 7, right? 7 times 1 is 7. And then in this new collection, this transformation, we have 7 still for our first entry. And then you get to the second 7. It comes in again as 7. And this time you increment multiple again. But remember, last time through the loop, it went up to 1. So this time it gets bumped up to 2. You have n times 2 is equal to 14, and that gets put in your second slot of your new collection. Similarly, through the third and remaining iterations, you see how this multiple increases by 1 every time, and we keep multiplying it by 7. And you can imagine how that would produce the result that you would want. Again, you have to convert it to an array because that's what the method specifies here. And so let's give this a go. Oh, sure. As usual, if you'd like to pause, figure out what I did wrong. The enumerable does not exist in this context. They're saying line 6, but do you remember what I did previously? We had to bring in link to use these features. I'm sorry, as far as enumerable itself, yeah, system link. So adding that line should help us. And there we go, test passed. You know, I didn't pay attention to the times before, but these inputs are so small that I don't know that they're going to be very meaningful, but hopefully you can see how this way was a lot better in terms of space that we used. We performed less operations too with our select statement as opposed to the where filter that we had before. So I'm sure there are many other ways that you could have done this. If you have a way that you like, please share it. Otherwise, hit me up with questions, and I hope you found this helpful. Thanks for watching.